Hello, everyone. We are honored to have the opportunity to talk with all of you today and really appreciate you spending your time with us. Please take a moment to read this slide. We receive feedback like this from students every day. It's a constant reminder about our mission and is our inspiration and passion and why we do what we do. We have heard from thousands of students and interviewed hundreds of faculty, and there are common themes we hear time and again. At its core, most students want to do well, to learn, to grow, to have a career, to contribute, but they need help getting there. Our focus today is on an important component to improving student success, and that's the use of adaptive technology and how it can help remediate students at the course level, at the assignment level, at the problem level, but more importantly at the moment of learning. This is where we get personal and can really help students with one-on-one feedback and coaching and move the needle on the number of students passing the course. Cornerstone to this goal is helping students realize they are capable of learning the material, that there is hope for success. But having students experience a series of mini wins within our software early in the course, we have been proven to improve test scores at least a full letter grade and increase student confidence. We need to break the cycle of frustration and embarrassment when it comes to learning these core developmental math skills, whether it's a college student struggling or a parent who can't help their fifth grader with their math homework. Here are the key features that we have researched, proven effective, and have incorporated as standard learning tools within our software. What students value most is the step-by-step feedback and coaching while working on problems and the ability to ask questions just as if they were talking to the instructor. We're looking to scale this technology to more topics and subject areas in developmental education, and to make this technology available to community colleges on a national scale. This is where we'll need your help, which we'll discuss shortly. But first, I'll turn it over to Benny to explain the difference between adaptive diagnosis and adaptive learning. He's going to give you a technology demonstration and discuss the performance results from a recent study just completed for developmental mathematics. With that, I'll turn it over to Benny.
Thank you very much. And here we see a slide that compares a typical software package used by a textbook publisher. In this case, it's McGraw-Hill's LearnSmart system, with a quantum tutor on the right. We're looking at the same problem. In this case, it's a problem from accounting on calculating interest for a loan. The term adaptive gets applied a lot to software, and it gets applied in a broad and varied sense. The term adaptive is used to mean many things in many ways, and so it's useful to talk a bit about what research has shown to be the most effective adaptive learning features in terms of getting the best student gains, and so we'll talk about that a lot here. In this case, in the software on the left, we see that we're given a set of multiple choice answers. We pick one. In this case, we happen to pick a wrong one. And what are we given? We're told our answer is wrong, and we're shown a calculation of how to do it the right way. This is what's called adaptive diagnosis. I can be given many problems of this type, and based on counting up how many I get right and wrong in each category, a picture can be made of what I know and what I don't know, what I still need to learn. The limitation, however, of that approach is that once it's known what I need to learn, when it comes time to get help and remediation and tutoring on that material so I can learn it, I'm not able to get any help. Note that as a struggling student, I can work this problem, and I could get an answer that's not A, B, C, or D, yet the multiple choice software forces me to pick an answer that may not even correspond to what I did. Also, by just being told wrong, try again, and maybe shown how to do the problem the right way, I'm not given feedback on why I went wrong, where I went wrong. the details of my incorrect reasoning that might have led to my answer aren't able to be addressed. And this brings us to one of the most important adaptive learning features that research has shown to give good student learning gains, and that is error-sensitive feedback, which is just like it sounds. The nature of the feedback that I get depends on the characteristics of the error that I make. If two students make two different kinds of errors, they ought to get different responses, each targeting the individual student's misconceptions. And that's what we have in the quantum software on the right. First of all, note that on this problem, I'm able to enter my own answer. I'm not forced to pick multiple choice. When I enter my own answer, then I get feedback that is specific to the nature of the error that I made. And we'll see that a lot more in the demonstration that's going to be given in a minute. Also, a unique feature of our software is that you can ask questions. The student can ask the tutor questions to follow up and get more information and insight into what's wrong with his answer and what is going on with the problem. So with that said, let's talk about the big picture challenge for these adult developmental math students. The problem here is that, unfortunately, these students likely have a long history of struggling with mathematics. So not only have they acquired some incorrect learning strategies, some bad habits, some misconceptions, but they're likely to view mathematics as something that they just can't do. They don't view themselves as being able to be successful with mathematics. In other words, their self-efficacy about mathematics is really low. So not only do we have to unteach the misconceptions that they've acquired along the way, we have to do as much as we can to improve their self-efficacy, to improve their belief that they're able to be successful in math. The goals of the Developmental Math Project are summarized here, and they're fairly self-evident, but the challenge is how to accomplish these goals, how to make meaningful progress on them in the software package. And that's one of the things I'm going to be pointing out and illustrating as we do a demonstration. I'm going to bring up one of the artificial intelligence tutors and play the part of the struggling student working through a problem. Now, here's something that's very important to note before we go into the demo. The interface that I'm using here allows me to select the type of problem I want. It generates a problem and tutors me through it. But that's not the optimal way that we envision this software being used. Research has shown that for these developmental students who are struggling with math, a more effective way to help them acquire the math skills they need than traditional drill and practice is to integrate the mathematics learning with the career and technical education that they're already working on in their curriculum. And so I want you to imagine this tutoring occurring integrated and embedded with the curriculum they already use. How is that possible? One of the main features that we designed in our artificial intelligence engines from the start is the ability to accept problems from an outside source, whether it's the student typing the problem in or whether it's a problem that came from the student's own textbook. But we feel it's critically important that students be able to get support in their own curriculum. And again, research has shown that particularly to be more effective for these developmental math learners. This came way back from the start when we began in chemistry. We envisioned a student who is struggling with their homework. They get stuck on a problem and there's nobody around to help, which is typically when they get stuck, when there's no one to help. They can't go see the instructor. They're not at school. A lot of times their parents can't help them with a subject like chemistry, and so they're on their own to do the best they can. If I came to you for help with a problem that I was struggling with, of course, I would show you the problem, you would look at it, and you would help me get on track on the very same problem that I couldn't do. What you wouldn't do is say, well, here's a list of problems that I always use. It's the same 5 problems always on this sheet. And you can pick one of them, but I'm not going to look at the problem that you're stuck on, which is more typical of what software programs do. Of course, it's key for students to get help on their own problems. And so that's why we designed our software from the start to be able to accept problems from the student or some other outside source, like their online textbook or homework system. That way they can get help on the very same problems they need. And this feature is unique to Quantum, even among other artificial intelligence software packages. Other packages do a great job at what they do with artificial intelligence, but they're typically their own curriculum or their own set path through a series of problems. They're not designed to support an existing curriculum. They're designed to be used standalone. So let's imagine doing a problem like this in the context of the student's own curriculum. We see it generates a problem that's practically oriented, and this problem was taken from an actual developmental math textbook to show that intended use. Okay, as we said, these students have acquired some incorrect learning strategies along the way, and so our approach is to model good strategies. We model a strategy that is direct and effective, will always work, will always succeed, and we let the student carry out the steps in that strategy that we model. And so here in this case, we're wanting to multiply a couple of fractions. And the first step is to take one of the operands, which is a mixed number, and convert it to a fraction. And so I'm going to play the part of the student. We need to convert 7½ to an improper fraction. So I may have no clue at first what to do, and so I just might make a guess. Well, the fraction part is a half, so I'll just put in a half and let's see what happens. Okay. Now the feedback says if the numerator is less than the denominator, then that means the fraction is less than 1. And we know that the mixed number has to be greater than 1 because it's equal to 7½ 7 plus a half. Looks like I only put in the fraction part of the mixed number. A couple of points about this. First of all, it's quite clear that we see the error-sensitive feedback feature at work. This feedback is very detailed, very specific to the type of error that I made. It's a lot different from the approach that we saw in the textbook publisher system in the slide early on, where we were just told wrong and here's the right answer. So we got feedback that's very responsive to the type of error that I made. Another feature, which is perhaps not so evident at first, is also very important. Notice that the feedback talks to me about how I could judge if my answer was reasonable. I put an answer that's only equal to a half, but we're looking for an answer that's equal to 7½ a number much greater than 1. And so it's showing me a way to think about my answer in a metacognitive fashion. And this brings us to a second major feature that we employ that research has shown to be one of the most effective adaptive learning features for getting good student learning gains, and that's metacognitive prompting, both domain independent and domain specific. Here, obviously, we're doing domain specific metacognitive prompting. But along the way, our tutor takes the opportunity whenever possible to explain to students how to judge if their answer is reasonable, using their own answer as the basis. And again, that metacognitive feedback has been shown to be one of the most effective adaptive learning features that we can do. Okay, so I'm going to go ahead and be the student. I'm catching on a little bit. Oh, yes, I forgot to include the whole number part. And so that would be 14 halves and the 7 that I forgot to include. So I'll try 14 halves as my next answer. Now, of course, that's not correct, but I'm making some progress, and it's a different kind of mistake. Okay, so it recognized that I did that. I multiplied the whole number times the denominator. But it looks like what I did is I neglected the original numerator, which is in fact exactly what I did. Notice again the error-sensitive feedback feature at work. I made a different kind of error this time, and I got a totally different kind of response. And so I make two different kinds of errors, I get two different kinds of response. This is very important, again, in achieving good student learning gains, as research has shown. So now, based on that, okay, I've finally got all the pieces together. I'll try again, and this time I got it right. So I'm ready to move on to the next step. And the last step, you see, I struggled quite a bit. I did a couple of wrong answers, coming at it from different directions. But with quite a lot of help and feedback and scaffolding from the tutor, I was able to get on track and eventually succeed in including the right answer myself. That's very important for students to be able to make learning games, that they're able to construct correct solutions, even if they make mistakes along the way and require quite a lot of scaffolding along the way. All right, so in our next step, we simply multiply the two fractions. This gives us the opportunity to look at another key feature of the quantum software illustrated on the right, which is ask a question feature. You may have noticed this when we were doing the last step, this menu of questions. And you may have noticed that when we come to this step, the menu changed. These are questions that the student is able to ask the tutor along the way to get more help, to get more clarification. These aren't questions the tutor asks the student, but again, the student asks the tutor these questions. So for example, I can ask, how do you multiply two fractions? That's what I want to know. When I ask that, I'm given a short explanation and a little worked out example to follow as a model. Where do these questions come from? They're not the same every time. They change depending on the details of the problem, what we do in the problem, and also how far along in the problem solution we are. These questions are not arbitrary, but you can think of them as this. We interview subject matter experts, master teachers, people who have had a lot of experience in teaching these topics, and find out what questions students ask the most in their classes, in their tutoring sessions, and their office hours. So these basically represent the frequently asked questions that good instructors feel that students will be likely to ask or should be thinking about to ask as they work through a problem. And so the questions are not arbitrary. That's how we obtain them. We don't claim that these questions are the only good questions one could ask about a problem like this, but we do claim that these are the questions that a student should be thinking about and should be able to answer as they work through a problem. And so if they're not able to answer them yet, they can ask the questions, study the answers, and learn. You might wonder, why don't we just provide a blank box and let the student type in any question they want? And that seems quite reasonable at first, but in fact, research has shown that when students are able to ask any question they want, for example, in a dialogue with a human tutor, they actually do that quite infrequently. There has been studies of human tutoring sessions that show that students initiate non-trivial questions very, very infrequently. They'll ask questions like, is that right? Or they'll ask for clarification, but it's actually much less frequent than one would probably think, where students originate good questions on their own. When we think about these developmental math students, maybe that makes a little more sense. If anyone has worked with a struggling student, if you imagine asking that student, what questions do you have about this problem? I'll answer your questions, and that'll help you get on track. We know that it's extremely common for the student to say, I don't know what questions to ask. That's part of the problem. That's why I'm stuck. I just don't know what to ask about this problem. And so the approach of this Ask Questions feature, which leverages the simulated reasoning of our artificial intelligence to create these questions, is that's okay. Here are some good questions to ask. Here are some things that are helpful to think about. These are the kind of questions that people who are successful at this are able to answer. And so if you get to where that you can answer these questions, then you're succeeding as well. And that is one of the ways that we aim to improve student self-efficacy. Long before I master everything to be known about fractions, and that's a goal that I might never completely attain, I'll be able to answer questions like this that I wasn't able to answer before. And when I can do that, my confidence, my self-efficacy legitimately goes up a little bit. Okay, having explained that, then let's just go ahead and do this, and I'll just go ahead and multiply these across. And I got the right answer in this case. I made mistakes, so I got feedback like we saw in the previous step. The final step, or the next step rather, in this problem is to simplify this fraction to its lowest terms. Notice that our questions menu changed over here. We get several questions about how to simplify fraction. In this case, all we have to do is divide out a 2, and we've got it. And so I'll do that. But I'll point out that if there had been multiple factors to divide out, we could do it either all at one time, or we could do it in steps. For example, if there'd been a common factor of 4, I could divide the 4 out right away, or I could divide out a 2, check that that was all right, and then divide out 2 again. And it'll allow me to do it either way to support whatever I want to do. Okay, so it tells me that's right, and since it's 60 over 1, this is just the whole number 60, and so I'm done with the problem. So we have seen some very important features already demonstrated. We've illustrated 2 features that research has shown to be among the most effective for improving student learning gains in adaptive learning software, and those are error-sensitive feedback and metacognitive prompting. We've also talked about how this artificial intelligence software can be used in the context of the student's own curriculum in a tightly integrated fashion, supporting their own problems, which research has also shown to be a more effective approach for these developmental learners. I want to show another feature that research has also established to be very important in obtaining good student learning gains, and that's mastery learning. On this tab next to the tutor, we see there's a page called How Am I Doing? And this is simply a mastery learning feature. We have listed out the goals that we want to master in learning about fractions in this module. For example, the first one we see is one that we just worked on, converting a mixed number to an improper fraction. And over to the right, we see some color-coded cells that tell us our progress towards mastering those goals. You can basically think of mastery as getting 3 right in a row without needing any help from the tutor. Now, different topics might need a different, maybe a little more sophisticated definition than this, but that's the concept. Can I do a few right in a row without needing any help? And when I can, that's evidence that I have mastered it. Mastery learning is very important. We've probably all heard about the 2 sigma holy grail of human tutoring, which is the belief that human tutoring is worth about a 2 standard deviation improvement in achievement relative to regular instruction without tutoring. And that's based, of course, on Bloom's experiments from the 80s. Well, since then, other research and meta-analyses of research on human tutoring has shown that human tutoring is not really worth quite 2 standard deviations. It's still very, very effective, but the mean effect size is more like 3/4 of a standard deviation, not 2. And what's the difference? Why was 2 standard deviations found in those experiments in the 80s? One reason it's believed that the standard deviation improvements were so high in those experiments was that in those experiments, Bloom included a mastery learning requirement, which means that students had to demonstrate a certain level of proficiency on a post-test before they were allowed to move on to the next topic. If I didn't pass the post-test with a certain score, I wasn't allowed to move on. I got more tutoring until I did reach that desired level of proficiency, and so that's mastery learning. Notice this is not at all what we typically have in a course. At the end of the chapter, we take the exam, and no matter if we pass or fail, we're moved on to the next chapter. And so that's not mastery learning. So mastery learning research has shown also to be extremely effective in producing good student learning gains. And so we include that feature here as well. I can see my progress towards mastering a goal. If I want more practice on a certain goal, notice in the last problem that we did, I didn't do that step without help. I needed some help to get it right, even though I did eventually succeed. So I don't have any progress towards that. I can go back. I can ask the tutor to generate me another problem that targets the mastery learning goal that I just clicked on. And so here I'll just go ahead and do this one real quick, converting the mixed number to an improper fraction. I got it right. So if I go back to the How Am I Doing report, now I have one problem, it's progress towards mastery. And so that's very simple how that our mastery learning feature works. It's quite convenient for the student to be able to do that. And we've studied this feature in a couple of papers that I'll talk about later on. Okay, well now I'd like to switch gears for a bit and talk about the instructor experience with the software. We've showed a lot from the student's perspective, and also we've been demonstrating the online system, which runs on a server. You can access it from anywhere, any computer, any tablet, anytime. And so when I talk about the instructor experience, perhaps I'll say that from the perspective of how that we can export data and manipulate data from the system, because that's very important as well. So I'm going to show you a report from an Excel spreadsheet that was generated by our system. So this is an instructor's report for the topic of fractions. It shows on the first tab at a glance what percentage of the class has achieved various mastery levels, high, medium, or low, and then also what percentage of the class hasn't done any work yet. Also, by the individual learning goals that we saw, we see where the class average started out initially, and then where they ended up after using the tutor, and so the amount of improvement that we got, or the class from using the tutor. We can also see a breakdown student by student in terms of how much time did they spend, how many problems did they do, how often did they just ask to see the solution to the problem. We can do that in the tutor. You know, this is tutoring, not testing. A student can ask to see a worked out solution, and the tutor will provide it. A lot of students in our study actually did that, or some students did, and used that as a model before they tried it on their own, and that worked well for them. We can see how often they required help to solve a problem and how often they were able to do it without help. And again, we can see that breakdown student by student. We can also see a similar kind of breakdown by those learning goals, how often they were able to do the goal without help, with help, and so on. We can see the questions that they asked and how often they asked, so we can get a picture of what questions are being asked by this class the most. And then we can see a breakdown student by student of the individual learning goals, the mastery status of each student on that. This is very important to be able to export data, manipulate it in this fashion for including grades in an online grade book. This is just an Excel format again, so that's important. It's also important for administrators who might want to get a picture not only at a class level, but at a school level or a district level or any kind of level if they'd like to see a rolled-up summary of the data. So it's important that we be able to take the data from our system and export it in a format that is compatible with the needs of the teachers and administrators that want to use it. Okay, at this point, I'd like to show you a few results from a small-scale study that we've done on the developmental math project that I've been showing you. This is from the Department of Education, Institute of Education Sciences, that funded this work. And so we did a small-scale study as part of that work. We evaluated 3 topics, and we did a very simple study. We gave students a pre-test. We had them use the tutor. We told them to use it to mastery, basically turn the how am I doing report all green. Most of them did that, some didn't. And then we gave them a post-test of comparable difficulty. And so here's a summary of the results. As we see, we got some quite good gains and some quite respectable effect sizes between 1 and 2 standard deviations. Now, I'll say that as we progress and the software is used in the optimal fashion as intended, integrated with the student's own curriculum, I wouldn't expect gains of quite this magnitude to persist, because due to the timing of the study, we weren't able to do it when this particular topic was being covered in the course. And so it was out of phase in that fashion. It also wasn't relative to a control group. So we wouldn't expect to see 1 and 2 standard deviations all the time, but we would expect to see the medium to large effect sizes that we have typically and consistently seen in studies in other areas. Another thing that we did on the pre and post test is we included some purely conceptual questions. You see in the demonstration that we are doing tutoring on problems that are more computational in nature, the common types of problems that you see in curricula. But as we also saw, the tutor brings in conceptual reasoning as much as it can in its responses and feedback. And so we wanted to know if we included purely conceptual reasoning questions on the test, then would we be able to see any gains? Even though the tutor doesn't explicitly address those questions, it does include them in its feedback. And we actually did see an effect. Here we see on percentages and probability, we didn't include them for fractions, a medium effect size and improvement on conceptual questions between the pre-test and post-test. So that was very encouraging. Another area that we investigated in this small-scale study was outcomes from the affective domain. It's being recognized more and more that it's important to study these affective outcomes, like attitudes towards mathematics learning, again, self-efficacy, belief that we can succeed, and so on. It's being recognized that these are not separated from problem-solving outcomes. They're related to them. They impact them. This really makes sense when we think about these developmental mathematics learners because, again, they have a long history of struggling, and they've developed a belief that they just can't do math. It's something they're not successful at. And so if I have that attitude, if I figure, well, what's the point? No matter how hard I try, I'm probably not going to succeed. Of course, that's going to depress my problem-solving performance. And so we need to study the problem-solving outcomes together with outcomes from the affective domain. We asked students about their comfort overall with solving math problems, how difficult they perceive the problems on the pre-test and post-test to be, how clear they perceive those problems to be. And we had them rate these things on a 7-point symmetrical Likert scale. So what did we find? Well, first of all, let's note that for problem clarity, students gave that a pretty high rating, even on the pre-test. And also, there was no statistically significant difference between students' perception of problem clarity on the pre-test and post-test. And so that means the students understood or felt they understood what the problems were asking them to do. So the issue with them struggling was not that, well, I'm not sure what this problem means. They felt they understood what the problem means, but they weren't able to do it. When we look at the ratings for problem difficulty, we see a different picture. Between the pre-test and the post-test, we do see a statistically significant difference in the ratings of problem difficulty. And the effect sizes are medium to large, and they're negative. And the negative sign means that students are perceiving the problems as less difficult on the post-test as on the pre-test. This is a good thing because actually the problems that we put on the pre-test and post-test were of comparable difficulty, but students perceived them as less difficult on the post-test. So after working with the tutor, they felt that the same problems were less difficult. This rating of mathematical comfort applies to how do you feel about solving mathematics problems in general. And for the most part, we didn't see a statistically significant difference in that rating from the pre-test to post-test. But on fractions, interestingly, we did. We saw a medium significant effect size. And that's very encouraging because we wouldn't expect tutoring on 2 or 3 individual topics necessarily to improve or change a student's overall comfort with doing math. But the fact that we did see that for one of the 3 topics is a bonus. We also had students rate on the post-test how helpful they felt the tutor was to them. And we see ratings from 5.6 to 5.7. And again, that's out of a scale of 7. So that's pretty good. The students were perceiving the tutor as pretty helpful to them. Here we say that our software has proven to improve test scores at least a full letter grade, and that's because in the various studies that we've done in many different subject areas. So we started in chemistry, and we've done math, and we've done accounting and business, and we've even expanded into special education and Braille, as I'll talk about a bit in a minute. The effect sizes that we consistently see correspond to improvement of a letter grade or more. This slide shows some survey data from students who have used the tutor and shows how that their confidence in the material has increased after they use the tutor. So to begin with, About half of them have medium confidence, and not many have very high confidence. After using quantum, it's split about a third each in medium, high, and very high. The reason the medium went down mainly is because the very high went up, and the students rating high confidence also went up quite a bit. This slide provides an interesting perspective that's a little bit different. We ask students to rate the helpfulness of all the resources that they have available to them in the course, so including the textbook and even help from the instructor. Quantum, as you can see, was rated the most helpful out of all. It's even rated higher than help from the instructor. Now, what does this mean? It doesn't mean that we think the software can do a better job teaching than an instructor can. That's not the case. What it does likely reflect is availability. I can get the online artificial intelligence tutoring software 24/7, anytime that I need it. I can't get access to the instructor anytime that I want. And so since the tutor does provide a very high quality level of tutoring, that combined with its ability to be used anytime is responsible for it getting the most helpful ranking. It's also probably the reason why the tutoring lab is down at the bottom. It's only open certain hours, and also when I go there, the quality and consistency of the experience that I get varies a lot according to students, and so that's probably the same factor that's coming into play there. In the middle, we see the textbook, and so the quantum tutor and instructor are both rated more highly as being more helpful than the textbook, which makes sense because that relates to the idea of adaptive diagnosis as well that we saw on the slide comparing the LearnSmart system. The information that I need to get help is probably in the textbook. It's definitely in there. But it's up to me as a struggling student to find the right information, dig it out, and figure out how it applies to my own situation. And so the reason I said it's comparable in a certain way to the textbook publisher software is that likewise, it can't respond to my own errors. It can't respond to my own mistakes and give me feedback that's specific to me. As I've said several times now, research has shown that this error-sensitive feedback is one of the most important features that we can have in improving student learning outcomes. And so that comes into play quite a lot, I believe, in the students' ranking of the helpfulness of the various features. This slide shows a few selected recent papers that we've published on various areas of our research. As you see, we really strive to take a research-oriented approach to the development and evaluation of our software. And so these are a few recent papers. If anyone would like to get copies of these papers, they can email us and we will send them right out. But here are a couple of recent papers on documenting the advocacy of the artificial intelligence tutors, one in chemistry and one in accounting. This paper on cognitive load was a study in accounting using the targeted practice feature that we saw illustrated during the demo. We found that students in introductory accounting were not only able to get more efficient use of their study time, but they got better learning gains and, in fact, got better knowledge transfer on a post-test relative to students who studied the same way and even used the artificial intelligence tutor, but in a fashion that was more consistent with what the textbook approach was. And to make the long story short, we found that the reason for those improvements is that our targeted practice approach reduced students' extraneous cognitive load. The mastery learning feature was studied by one of our colleagues, Carol Sargent, in her course on intermediate accounting, and found that not only did the mastery learning requirement on some prerequisite material improve the final outcome on the final exam for the course, but also it improved students' effective outcomes. They believed that the course was more valuable to them and they felt better about their own performance in the course by requiring this mastery learning feature. The last paper is a feature that I haven't mentioned up to now, but it's very important to us, and it's accessibility and 508 compliance. We have included accessibility support for students with visual impairments for a long time, beginning with our chemistry tutors, and that's what this paper is about. But I think I did briefly mention before that we have since gone on and developed an artificial intelligence tutor to help blind and visually impaired students learn Braille. And so that support has been integral to our efforts in developing these tutors because it's an area that's very near to us. As we mentioned at the start of the demo, it's very important that this artificial intelligence software can be integrated with the student's own curriculum. It's not separate and standalone like other software packages are, whether they're the simple textbook publisher software packages or whether they're the more advanced artificial intelligence software packages. Our approach is different. We're not a curriculum. We're a tutoring service that can be integrated with the problems that the student is already going to be doing, and that can add significant complementary value in a way that other software packages do not. And so we should envision this software being used, integrated tightly with a CTE curriculum as the student works through it to get tutoring in context, which provides a great benefit. We know that one-on-one tutoring is one of the most effective things that we can do to improve student outcomes. We talked before about how that one-on-one human tutoring on average has been shown to be worth about 3/4 of a standard deviation improvement relative to instruction with no tutoring. But it's also been shown that well-constructed intelligent tutoring systems also average about 3/4 of a standard deviation in student improvement. And so that's a very exciting prospect to be able to deliver that in the student's own curriculum and context. It can provide quite a lot of benefit. So at this point, I'd like to hand it back to Rebecca. Thank you very much.
Thanks, Benny, for that really great demonstration and summary of our research. Note that there's much more work to do, and we're seeking collaboration to help us. We need to define what additional content to develop. We're seeking partners for national or statewide field testing and dissemination. And finally, as a small business, we need funding and investment to help scale and build new content and features. Thank you so much for attending today.